Hi there, this is Dr. Everybody, and I want to talk a little bit about problem solving today. We've reached the point in the course where it's time to reflect on what we're doing and some of the techniques that we have. Maybe that'll help us, maybe that'll help you as students attack some of the more difficult problems that we'll have coming up. When Dr. Punch and I created this course, we wanted to focus on problem solving. And one of the best books on problem solving is this book called How to Solve It. It's a very short volume. It was written many years ago in the middle of the last century, in fact. But to date, it's really still the best book on problem solving. And what I want to talk about in this video is what we can learn from that at this point in the course. So let's take a look at it. So the book was by a guy named George Polya, a famous mathematician, and it's called How to Solve It. And it's still in print, even though it's 75 years old now at this point. And the principles that they had in there were, first of all, to understand the problem. I'll talk more about these. The other is to devise a plan. The other is to carry out the plan, and then finally the one that's often overlooked is to review, reflect, and see if you can extend the problem. Now when you look at this, hopefully these look like things that are pretty obvious. Of course you need a plan. Of course you need to carry it out. Of course you need to understand the problem. But let's take a look at what these might mean in a practical sense for you as as students learning to solve problems with computers. So first of all, you need to understand the problem. You'd think this would be obvious, but it's not. And one way to look at this is, what are some of the questions that you might ask? So what are you asked to do? Do you actually understand that? And you need to spend some time trying to figure that out. Can you restate the problem in your own words? If you can't, you probably don't understand the problem. And this is what is nice at the problem solving stage, to work with somebody else. Can you tell the other person what this problem is about? I find that when I help students, that's often one of the things that they haven't tried to do. Can you, at some point you need to own this problem. Maybe you can draw a picture or diagram the steps that will help you understand the problem. If it's a card game, get some cards out and play with some cards. Anything you can do to help you better understand it. Is there enough information for you to find the solution? Now, in our projects that we have for 231, we hope that we give you enough information to solve it, and that's part of our task in terms of specifying the problem. But in other domains, other situations, that's actually a very important question to ask. And do you understand even all the words that are used in it? Seems pretty obvious, but make sure that you do that, and that's obviously related to the second one. And again, okay, what are the questions that you need to ask in order to solve this problem? Now, this of course relates very much to this course. Right? I've got a problem. I'm struggling with it. What is the critical question to ask to get this, to move me on to better understanding this problem? And that's non-trivial. Just to say, I don't understand, that's not very useful. If you can say, gee, there's this task or this function, and I don't really understand what it's doing or why it's there. Well, that's a better question. Now we've narrowed it down, and you can start to think about things like that. So understanding the problem, it should be obvious, but you need to spend time on that. Devise a plan. Well, of course you need a plan, but let's think about what's involved in creating a plan. And the one way I like to think about it is that inside any complex problem is a simpler one. And your task is to find that simpler one. And by the way, this is the hardest part of problem solving, in my from my experience, particularly the kinds of problems that students are struggling with in 231. How do I find the simpler stuff? Many times I help a student, break it down into something, and they go, "Oh yeah, I can do that." That's what you're really asking? Oh, I could do that. And so that's actually the biggest challenge in this course. And so you've got to identify those simpler problems and solve them. And you'll notice that in some of the programming projects, I say things like, "Oh, don't worry about the error checking. Leave that. That's an important part of your solution, but it may not be the core of the problem that we're facing right here." And so it can kind of clutter up the finding that simpler problem. You always want to be looking for something simpler. Yeah, there really is something there that I can solve. Make a list. Start jotting down. Oh, I'm going to do this, and then I'm going to do that, and then I'm going to do that. Okay, so I can do steps 3 and 5. I already know how to do that. I know how to open a file. I can do that. I've got some functions that do that. So here are the things I got to print some stuff out. Yeah, I can print stuff. I can format stuff. So now, okay, so you're peeling away stuff to get to the smaller problems, and also look for patterns in there. We have a lot of patterns in this course. Oh, I've got a list, and now I'm going to read through a file. I'm going to pen stuff onto the list. Oh yeah, there's a pattern I recognize. I know how to do that. And then set aside some of the subproblems to work on later. Maybe there are functions. All right, let me work on. Hey, let's do the easy functions first. I know how to open a file. Let's get that taken care of. And some of the harder ones, maybe you'll leave those for a little later. And you'll find a certain satisfaction of working on those. So you've got to identify, you've got to decompose this problem into things that you can work on. And it may be useful to draw a diagram for how these subproblems relate to each other. Oh, this function does this, and then it passes some information back that I can use in this next function. And it may be best to actually start drawing this out on a piece of paper. Many times that's the way to do stuff. When I work with students in some of my research groups, frequently we've got the whiteboard out there, we're marking it up, and if the problem is complex, we're breaking it down into simpler ones and saying, okay, we're going to do this, and then we're going to do that. And drawing it out is very helpful. So, So a couple of things that we know about problem solving. One is you got to have time to be able to set it aside when you're stuck. We know that about problem solving. When you get stuck, if you're just staring at the computer and getting nowhere, you got to walk away from it. Get some help. But time is important. If a project is due on Monday night, you can't start it on Monday. It doesn't work. And there are some parts of problem solving that are best done with others, and there are some parts that are best done alone. At the highest level in our course, we want you to work out problems with others. All right, sort of like at the stage where you're not talking about any Python. And then we want when you're and that way you can map stuff out. You can describe the problem to somebody else. You can get many of your questions answered and formulate the questions that you need answers to. And then there are other parts that are best done alone. And in fact, in 231, we require that you do the Python parts by yourself. And of course, you got to carry out the plan. And many, in many cases, because we're talking about programming here, that's actually putting your ideas into code. And if you've got a plan that has sufficient detail, carrying it out can be relatively easy. Right? The hardest part is the problem-solving part, and it's that. And students frequently mix up the problem-solving with the coding. They're trying to do the coding before they've got They have a real plan in mind. And that's the hardest way to do it. And that, in fact, takes the most time. If you get a good plan, the programming goes pretty smoothly. If you have a lousy plan, the programming takes forever. And now the last step is to review and reflect on it. And let's face it, you've spent time, you've got the programming project done, you hand it in, and you are ready to. You've seen enough of it. Right? But the reality is that the best learning about problem solving involves, some time later, maybe when the grade comes back, that you can actually take a look at the solution and reflect on how you could do it better, what you learn with it. And it's actually a very valid question to ask of a teaching assistant, which is, hey, I handed this thing in, and I want some more feedback on how I could have made that better, right? And that's part of our value added here, and that's a very valid question to ask to take care of this stuff. So my idea was that at this point in the course, we need to sort of reflect on problem solving, and hopefully this little video helped you along those lines. So good luck.